Working of a PNP transistor. A PNP transistor is like two PN junction diodes which are placed back to back. At each junction, there is a depletion region which gives rise to a potential barrier. The external biasing of the junction is provided by the batteries VEE and VCC as shown in figure. The emitter base junction is forward biased and the collector base junction is reverse biased. Since the emitter base junction is forward biased, a large number of holes cross the junction and enters the base. At the same time, very few electrons flow from the base to the emitter. These electrons, when they reach emitter, recombine with an equal number of holes in the emitter. The loss of total number of holes in the emitter is made by flow of an equal number of electrons from the emitter to the positive terminal of the battery. The flow of holes from the emitter to base gives rise to emitter current IE. In the emitter, IE is due to the flow of holes, but in the external circuit, the current is due to the flow of electrons from the emitter to the positive terminal of the battery VEE. The holes diffuse through the base. These holes take a very small time to flow through this region before they reach the depletion region. During this time, a very small number of holes recombine with an equal number of electrons in the base. Because the base is lightly doped and very thin, this number is very small. The loss of total number of electrons per second is made up by the flow of an equal number of electrons from the negative terminal of VEE into the base. The flow of these electrons contribute the base current IB. The remaining numbers of holes which do not undergo recombination process in the base reach the collector. These are neutralized by an equal number of electrons flowing from the negative terminal of the battery VCC into the collector. At the same time, an equal number of electrons flows from the negative terminal of VEE and reach the positive terminal of VCC. The flow of holes per second from the base to the collector gives rise to the collector current IC from the base to the collector. In the external circuit, it is due to the flow of electrons from the negative terminal of the battery VCC into the collector. Applying Kirchhoff's current law to the circuit, the emitter current is the sum of collector current and base current, that is, IE is equals to IB plus IC. This equation is the fundamental relation between the currents in a transistor circuit. This equation is true regardless of transistor type or transistor configuration. The action of NPN transistor as shown in figure is similar to that of PNP transistor.